You lie down. The room hushes around you, your breath soft against the quiet. Outside your window, the stars scatter like whispers in deep ink. And somewhere, not far from your thoughts, the universe opens a hidden door. Inside your body, in the atoms of your hands, in the slow tide of your cells, something familiar stirs. Protons and electrons, spinning gently in the hush of sleep. Tiny engines of matter. But tonight, you don't follow what you know. Tonight, you turn inward, toward the unseen reflection, the one you've never touched. You begin to imagine, what if every piece of matter had a twin? Not just a copy, not a shadow, but something stranger. An opposite. If you were made of bricks, your twin would be made of holes. If you were fire, it would be frost. Not evil, not wrong, simply inverse. Perfectly so. This is where you meet antimatter. The word itself is a hush. A breath through the mouth of science. Not something from science fiction or galactic war machines. But something born with the stars, as old as the first heartbeat of time. Close your eyes. Let yourself drift back, not just through years, but through eons, through the fabric of time itself. Float past the moon's formation, past the Earth's beginning, past the fire of stars birthing stars. Go back to the first moment. The Big Bang. There, a trillionth of a second after the beginning, the universe is a searing, expanding breath. Not silence, but pulse. Not structure, but possibility. And in that unimaginable heat, particles are born. Matter and antimatter, side by side. For every quark, an antiquark. For every electron, a positron. They do not fight. They exist together, like twins tumbling in the warm sea of birth. Identical in mass. Opposite in charge. If the universe were perfectly fair, they would have erased each other. They would have met, hugged, and vanished, in a spark of light. Complete annihilation. Energy from the kiss of opposites. But something happened. Somewhere in that beginning. A tiny asymmetry tipped the scale. Out of every billion pairs, one extra matter particle survived. Just one in a billion. And that one became everything. Your body. The ground. The stars. All built from what was left behind. And antimatter? It faded. Burned away in a final embrace. Rare. Precious. Nearly gone. But not forgotten. Even now, the universe still whispers its name. In high-energy places, like the hearts of stars or the collisions of cosmic rays with our atmosphere. Brief flickers of antimatter appear. Like sparks from a hidden fire. And here on Earth, scientists have learned to summon it. In careful chambers, inside magnetic traps. You lie still again, letting this thought press gently into you. That there are mirrors of matter, hiding in the folds of physics. Not malicious. Not fictional. Simply rare and waiting. Imagine a particle of antimatter, a positron, drifting near your fingertip. It is like an electron in every way. Except one. Its charge is flipped. Its nature is backward. And if it touches an electron, they vanish. Not into dust or ash, but into light. Gamma rays, pure energy. You might think of it as destruction. But really, it is transformation. The most elegant exchange the universe knows. 1 gram of antimatter meeting 1 gram of matter. The result is not just heat, not just fire. It is the energy of nuclear blasts, contained in the smallest whisper. A power so intense, so pure, it is almost poetic. You breathe slowly now. Not with fear, but with reverence. Because this is no bedtime ghost story. No fantasy of superweapons or star destroyers. This is real, and quiet. The science of antimatter lives not in movies, but in machines humming gently beneath mountains. In Geneva, at CERN, deep underground, scientists accelerate particles to near-light speed. Then watch them collide. From the debris, antimatter is born, not in rage, but in reason. It lasts for fractions of a second, cradled in magnetic bottles that must never let it touch the walls. Because if it does, it will disappear in a flash, returning to the stars the energy it borrowed. This careful dance is not for war. It is for understanding. To know what we are. And what we are not. You might wonder why we can't just collect antimatter. Keep it in jars. Use it for power. Use it for fear. But the universe does not make it easy. Antimatter cannot be held by hand. It cannot touch ordinary matter without ending both. It must be suspended, like a drop of rain floating between magnets. Even then, the cost of creating just one atom is enormous. Billions of dollars, days of energy, all for a few invisible specks. So when people speak of antimatter weapons, as they sometimes do, with furrowed brows and heavy headlines, they are not wrong to be concerned. But they may be dreaming too loudly. Because before we can destroy with antimatter, we would first have to possess it. And to possess it, we must understand it. We must court it gently, like a wild animal, or a mirror with teeth. You might now picture yourself walking in a quiet forest of atoms. Each tree a proton. Each breeze a field of electrons. And somewhere, hidden among them, an opposite, pulsing softly, unseen. Waiting. Not to explode. But to be noticed. This is how science begins. Not with fear. But with listening. Antimatter is not evil. It is not dangerous because of what it is, but because of what it could be. If misunderstood. You rest your head now. You feel your heartbeat, steady like a ticking clock. And somewhere in the rhythm of it, you sense the universe doing the same, ticking, turning, balancing opposites. You are made of matter. But in another version of the cosmos, one where the scale tipped the other way, you might have been made of antimatter. And you would have never known the difference. In that world, electrons would be positrons. Protons would be antiprotons. And everything, every star, every breath, every lullaby, would feel the same. So you wonder, why didn't that happen here? Why did this version of reality win? That's a question the universe still holds close, like a secret. But maybe, just maybe, the answer lies not in warheads or engines, but in the echo of the beginning. And so, as you drift deeper into stillness, you prepare to travel backward again. To that first breath of everything. Because to understand antimatter's danger, you must first feel its origin, its symmetry, its loss, and above all, its strange and beautiful birth. You drift gently into the hush before creation. Not darkness. Not silence. Not even emptiness. But something quieter still, the stillness before stillness had a name. Time has not yet begun. Space has no shape. And yet, in this breathless pause, everything waits. Then, not with thunder, not with chaos, but with sudden clarity, the universe inhales. A singular beginning. Not an explosion, like the ones we see on Earth. But a bloom, a flowering of time and space from a point smaller than anything you can imagine. A point of infinite energy, infinite potential. The Big Bang. You are not standing apart from it. You are inside it. Falling through its heat, its light, its newness. The laws of physics are being written in real time, not carved in stone, but unfolding like waves. And in those earliest flickers, the universe becomes a forge. Not of galaxies or planets, not yet. But of building blocks. Particles. the tiniest possible pieces of everything. Born not one by one, but in pairs, like dancers. Matter and antimatter. Each time one appears, its mirror appears beside it. Like breath and counterbreath. Like the beat and the echo. Proton and antiproton. Electron and positron. Quark and antiquark. Light and shadow, perfectly matched, perfectly balanced. In this new, searing sea, these twins swirl. They touch. They meet. They vanish. You see it, the rhythm of annihilation. When a particle meets its opposite, they disappear, not into void, but into energy. Pure, radiant light. A beautiful ending. And a beginning again. This is not destruction. This is balance. A cosmic dance of equals, creation matched by uncreation. And yet, the universe does not stay this way. The temperature cools, ever so slightly. The expansion continues. And somewhere in this vast, hot unfolding, a mystery is born. Because when the dance should have ended in perfect balance, it did not. Out of every billion pairs of matter and antimatter, one particle of matter is left behind. Just one. A leftover. A stutter in symmetry. A mistake, or a miracle. No one knows why. The laws of physics suggest balance. But reality remembers imbalance. You breathe slowly now. Because you are made from that 1 in a billion remainder. That survivor. Everything you see, your hands, the ground, the oceans, the clouds, the stars. Built from the leftovers of annihilation. You are made of what didn't cancel out. What tipped the scale? Was it a tiny asymmetry in a law we don't yet understand? Was it randomness? Or was there something deeper? Some scientists believe that CP violation, a quiet breaking of symmetry between matter and antimatter, played a role. Others think new physics is hiding in the folds of the early universe, waiting to be revealed. But none are sure. All we know is this. Somehow, matter gained the slightest edge. And that made all the difference. It's strange, isn't it? That you are here, reading, breathing, dreaming. Because of a slight imbalance in the rules of creation. The antimatter vanished, mostly. Gone in flashes of light, moments after its birth. And yet, even now, its presence haunts the cosmos. You follow that ghost. High above, in the vacuum of space. Cosmic rays, fast-moving particles from distant galaxies, crash into Earth's atmosphere. And in those collisions, positrons are born again. Fleeting twins. Brief flickers of the lost half of the universe. In giant detectors buried underground or orbiting silently in the sky. Scientists look for these remnants. They count them, trace them. Searching for hints of primordial antimatter. Not from collisions, but perhaps from ancient stars made entirely of it. So far, none have been found. You float in this thought. That somewhere, far beyond the edge of our sight, a galaxy of antimatter might exist. A mirror island in a sea of matter. But if it does, it keeps its distance. Because if matter and antimatter met in bulk, if galaxies collided, they would erase each other in light. And yet, the universe is strangely quiet. No great flashes, no annihilation on a cosmic scale. So you conclude. The antimatter is gone. Or hiding. Or never existed in equal measure at all. But the question remains, and it rocks gently in the cradle of your mind. Why? Why did matter win? It's a question physicists still ask. Not with fear, but with fascination. They recreate the conditions of the early universe in massive colliders. They build instruments sensitive enough to detect the quietest particle. They look into the symmetry that shaped everything. Because inside that question lies the key to your existence. Not just how stars formed, or atoms assembled. But why anything is here at all. You return now to those first moments. Not to change them, but to witness them more deeply. As the universe cooled, the surviving matter began to clump. Quarks joined to form protons and neutrons. Electrons whirled near. Atoms were born. Hydrogen first, the simplest. Then helium, formed in the hearts of stars. Everything else, carbon, oxygen, gold, would come later, from the slow fire of starlight. But it all began with that imbalance. That one breath of matter that refused to vanish. It is humbling to think how close the universe came to emptiness. A small difference in symmetry. And you would not be here. No stars. No galaxies. No thoughts, no dreams, no names to call home. Just light. A silent, endless bath of light. Instead, you sleep beneath stars. You walk on matter. You ask questions. And maybe, in your questions, you carry a kind of symmetry after all. Because if the universe once gave birth to balance and broke it, you are what remains, and what reflects. You are the echo of a mistake. Or the child of a secret rule. You hold both possibilities in your breath. And as you breathe out now, slow, soft, steady, you feel the warmth of creation still glowing beneath your skin. Not just stardust. But anomaly. Not just a life. But a leftover miracle. So you return to your bed, or your thought. Carrying this quiet revelation. That in the most delicate tipping of scales. Everything was born. And yet, if antimatter was once equal. If it shared the cradle of the cosmos with matter. Then what would it take to bring it back? Could we ever make it, hold it, use it? Or has it faded too far from reach? You close your eyes again. And prepare to follow this question. From the birth of particles. To the delicate power that sleeps in their annihilation. You close your eyes. The air around you is still, your breath slow. You feel your body melt into the quiet. Bones soft, thoughts open. As if the boundary between you and the universe has thinned. Now, imagine holding out your hand. Feel the space around it, the weight of skin and bone and blood. It's yours, formed from matter, built from the residue of that ancient asymmetry. Atoms turning slowly in the deep silence of sleep. Now picture its mirror. A hand just like yours, in shape, in size, in structure. But not made of matter. Made of antimatter. Not a ghost. Not an illusion. But a perfect opposite. Everything reversed, charge, direction, intention. And now, let them touch. Just the fingertips. In an instant, they disappear. Not into smoke. Not into ruin. But into light. Not just brightness. But energy, pure, raw, unchained. You have just witnessed annihilation. This is not violence. It is not rage. It is a quiet law of physics, patient, waiting. When a particle of matter meets its corresponding antiparticle, they cancel out completely. Not partially. Not with remnants. Completely. All their mass is turned into energy. Exactly as Einstein once described. E equals mc squared. Energy equals mass, multiplied by the speed of light, squared. Which means even the tiniest bit of mass holds vast, sleeping power. This is the fragile dance. Matter and antimatter. Attracted by nature, yet fated to vanish together. There's no hesitation in their meeting. No negotiation. Just instant release. Like two musical notes colliding into silence. Or two waves cresting, then flattening into sea. You feel the poetry of it. And also, the weight. Because a single gram of antimatter, if brought near 1 gram of matter, could release as much energy as a small nuclear bomb. Not in heat. Not in fallout. Just, light. It's strange, isn't it? That something so beautiful, so symmetrical, can be so final. You drift deeper into the science now, as gently as sleep. You learn without effort. Through image. Through metaphor. Like a child watching ripples in a pond. Picture an electron, small, negative, dancing through its cloud. And then, a positron, same mass, but positive. They approach. They touch. And in their place, you find 2 photons. Particles of light, spinning away from the scene. Nothing is left of the electron or the positron. Only energy. Only the memory of what was. It happens in laboratories. It happens in space. It happens even inside your body. Yes, right now, as you lie still. Small particles from space, cosmic rays, strike your atoms. And every so often, a positron appears. Meets an electron. And vanishes. You don't feel it. You are too large, too complex, to notice. But the universe notices. It always notices when symmetry is restored. You begin to sense the delicacy of this interaction. Why antimatter must be handled like a feather balanced on fire. Why even the air would destroy it. Why it must be trapped in vacuum. Surrounded by fields. Never touching the walls. There are no containers for antimatter in the ordinary sense. No jars. No boxes. Only magnetic cages. Suspended in empty space. Where the fragile twins can float. Alone and untouched. If they drift too far. Or too close to matter. The dance begins again. And ends in light. This makes antimatter both impossible and precious. A miracle to create. A terror to store. A wonder to understand. You pause here, breathing quietly. Because this annihilation is not just destruction. It is conversion. It is transformation at the most fundamental level. Matter becoming light. No smoke. No sound. No body to bury. Just photons, pure messengers. Carrying away the memory of mass. In the center of stars, fusion turns hydrogen into helium. In nuclear fission, atoms are split. But in annihilation, there is nothing left. This is why scientists are drawn to it. Not because they crave ruin. But because they crave understanding. And perhaps, one day, the energy of annihilation could be used for good. A spaceship powered not by fire or fuel, but by the meeting of opposites. A hospital scanner using antimatter to see deep within the body. As we already do with PET scans. Where positrons light up the map of your chemistry. In such places, annihilation is not an ending, but a signal. A flash of light that speaks. A disappearance that reveals. But always, always. The risk is there. Because the line between beauty and danger is drawn with precision. Too much antimatter. Held too loosely. And you do not get a whisper. You get a roar. So we cradle it with care. Create it atom by atom. Store it for seconds. Watch it vanish. And yet we persist. Because in every annihilation, there is truth. A truth about the nature of things. That opposites don't hate, they complete. That destruction is not always cruelty. That in some endings, light is born. You return now to your imaginary hand. And its mirror twin. You feel the ache of never being able to touch it. Not out of fear, but out of reverence. Because contact means erasure. Not one destroying the other, but both vanishing in union. It's easy to imagine annihilation as war. But maybe it's more like surrender. Matter and antimatter coming together with no resistance, no blame, and becoming something new. And maybe, just maybe, in that surrender lies a lesson. A lesson not about weapons, but about balance. Because if annihilation is a kind of peace, then what happens when we try to use it for power? Can something so delicate be weaponized? Can the universe's quietest truth be forged into a louder threat? You exhale now. Not in fear, but in contemplation. You understand the rule that when opposites meet, they give up their form to become something more essential. And in that transformation, you glimpse the edges of possibility and danger. So you turn slowly, facing the next thought, the next shadow, the next question. Not, what happens when they meet? But, what if we try to make them meet? On purpose? You imagine yourself drifting gently, slowly, into the earth. Through layers of soil and stone. Through time pressed into rock. Until you reach a place where the ground hums with cue. You yet intention. It is not loud here. It does not need to be. Beneath the surface, deep under the border between France and Switzerland, you find a cathedral of science. A circle carved not in marble but in magnets. A ring 27 kilometers wide, buried in silence. You are inside CERN now. Here, scientists do not pray, but listen. To particles. To echoes. To the tiny, invisible architecture of everything. And here, for the briefest of moments, they hold lightning in a bottle. Antimatter. Not as myth. Not as weapon. But as reality, rare, precious. And almost impossible to keep. You drift down a narrow corridor. Walls humming softly with cooling systems and quiet electricity. This is not the future of science fiction. This is the present, breathing. In one chamber, you pause. You are watching what no eye can see. A cloud of antiprotons. Suspended in space. Not touching the walls. Not drifting too far. They are kept alive by a dance of magnetic fields. Spinning and holding like invisible hands. Because if they so much as brush the container, they disappear. Annihilated on contact. Replaced by energy. So the scientists build traps. Not with bars, but with balance. Penning traps, they're called. A blend of electric and magnetic fields. Designed to contain charged particles in perfect suspension. Not touching. Not falling. Just floating. Like a dream you dare not disturb. You breathe slowly as you observe. There is no violence here. Only precision. Antimatter does not scream. It does not glow red or pulse with rage. It is silent. Still. And waiting. A whisper of it. A single antiproton. Can take hours to produce. At the cost of enormous energy. A gram? That would take centuries at current production rates. And billions in resources. So what they trap here is not quantity. It is knowledge. Confirmation. Proof that the mirror exists. You walk now past an accelerator. A great machine that speeds particles close to the speed of light. Not to crash them blindly, but to peel back layers of the cosmos. To reveal what lies beneath. When matter particles collide with enough energy, new particles emerge. For a heartbeat, some are their own opposites. Particles and antiparticles. Twins born in fire. And then, just as quickly, they vanish again. Unless caught. You see the alpha experiment. One of the few places in the world where antihydrogen is made. An antiproton paired with a positron. It's delicate, exquisite, and fleeting. To trap antihydrogen, the scientists must build a space colder than interstellar vacuum, emptier than space itself, and smoother than anything found in nature. Only then can they observe the mirror atom. Only then can they ask, does it fall up or down? Does it behave like hydrogen? Or does the universe play a deeper trick? These are not idle questions. They reach into the heart of symmetry. One of nature's oldest rules. And possibly, one of her most broken. You float past rows of computers, recording every flicker. Each annihilation leaves a signature. A burst of light. A trail of evidence. Like footprints in fresh snow. And from these patterns, scientists build understanding. Each annihilation is a message. A whisper from the other side of reality. You wonder now what it would take to hold a gram of antimatter. A gram of pure reversal. A gram that, if touched by matter, would release the energy of a Hiroshima bomb. What kind of container could cradle that? What kind of hands could dare? So far, none. Because antimatter is not just explosive. It is fragile. You cannot build walls around it. You cannot seal it in glass or metal. You must hold it without touching. Love it without embracing. Even the best magnetic traps can only contain it for seconds. Sometimes minutes. A breeze in the scale of time. So much effort. For so little. And yet, we keep trying. Not because we seek destruction. But because we seek understanding. Because inside that tiny cloud of antimatter, there is a question. And maybe even an answer. You imagine now what a world of antimatter might be. A planet, perhaps, circling a distant sun. Made not of rock and dust, but of anti-rock, anti-dust. Would it shine? Would it grow trees? Would it dream? If you could stand upon it and somehow survive, would it feel familiar? Or would it feel like touching your own shadow? But that's the thing. We can't touch it. Not yet. Because the moment you bring matter and antimatter together, they cease to be. And you are left with light. Beautiful. Blinding. Final. So scientists work with emptiness. With vacuums and coils. They build machines that barely breathe. Rooms that tremble at the arrival of a single particle. And in this delicacy, they find power. Not explosive power, but the power of restraint. You linger now at the edge of the chamber. You feel the stillness of the trapped particles. Their silent waiting. They do not know they are rare. They do not know they are feared. They are simply themselves. The other half. The half that wasn't chosen. And in their silence, you begin to feel the tension. Because if even a few atoms of antimatter require such effort, if storing them is like trying to bottle lightning, what would it take to turn them into weapons? What would it mean to try? You step back now, leaving the chambers of glass and coil behind. The hum fades. The silence grows deeper. Above you, the earth turns gently. The sky curves overhead. Quiet and vast. And yet, somewhere down here, in cold tunnels and suspended traps, The universe's mirror stirs. And waits. Not with anger. Not with purpose. Just with presence. You lie down again. Your thoughts still charged from what you've seen. You now know what it means to catch a speck of antimatter. To bottle it. To cradle it with fields and fear. And as you fall deeper into your breath, you ask yourself the question that scientists rarely speak aloud. If we ever did find a way, not just to catch it, but to use it, what price would we pay for that spark? You lie still beneath the quiet hush of night. The stars above hold their breath, as if waiting for your thoughts. And deep in your chest, a soft question flickers. What would it take to use one spark of antimatter? One particle. One meeting of opposites. One perfect kiss between matter and its mirror. Would it burn cities? Would it shift the balance of peace? Or would it simply fade? Unreachable and unreal? Tonight, you do not fear the answer. You explore it, gently, like a seashell pressed to your ear. You follow the rumor of power. To see if the whisper becomes a storm. You begin with a fact. A single gram of antimatter could unleash as much energy as 42 kilotons of TNT. Roughly 3 times the blast that devastated Hiroshima. No fuel. No chain reaction. No fission fragments or mushroom clouds. Just, mass turned into light. Instant. Complete. This is what draws attention. Why the word antimatter sparks headlines and speculation. Why some imagine bombs the size of teacups, able to flatten cities in silence. But as you rest, you drift gently past the myth. You let the layers unfold. Because power, you realize, is not just about what could be, but what is. And what is far less simple. To build a weapon, you would need fuel. Real fuel. Grams, not particles. Grams of antimatter. When today, all the accelerators in the world combined have produced only nanograms. Billionths of a gram. And even those vanish almost as soon as they're made. You recall the traps at CERN. The careful coils and magnetic prisons that cradle a few dozen antiprotons at a time. Their lifespan measured in seconds. Their creation measured in years. So to gather enough for a weapon, even just a coin-sized amount, you'd need a factory the size of a planet. Power stations beyond imagination. Technology that does not yet exist. And even if you made it, where would you keep it? There are no antimatter bunkers. No solid shells. You can't store it in steel or lead. It would touch the walls and vanish. The very act of touching becomes obliteration. So you would need vacuum. Magnetic suspension. Systems so sensitive that even a single failure would cause instant, uncontrolled annihilation. No warning. No pause. You breathe slowly as you weigh the cost. Not just in danger, but in effort. It would be easier, you realize, to capture lightning in a raindrop than to arm a nation with antimatter. And yet, the dream persists. Because power seduces. And where imagination leads, some will always try to follow. You picture, briefly, a spacecraft. Fueled not by flame, but by annihilation. Each meeting of a particle and its twin, propelling the vessel forward with unmatched efficiency. This is not fantasy. Not entirely. Scientists have studied such engines. Antimatter propulsion. A distant dream of interstellar travel. Because the energy is real. The math is sound. And in space, where vacuum is plenty, and mass is precious, Such engines could one day soar. But war. War is less patient. It demands simplicity, ruggedness, repeatability. And antimatter, for now, offers none of these. You think of the nuclear bomb. How it changed the world. Not just by its fire, but by its existence. It could be built. It could be deployed. It changed diplomacy. Tilted the world on an axis of fear. But antimatter? It hovers outside the circle. Too expensive. Too unstable. Too theoretical. So far. You feel relief in this. But also unease. Because the boundary between science and weaponry is not a wall. It is a thread. Thin. Winding. Worn by history. You remember how many discoveries began in curiosity and ended in arms. How tools become tactics. How dreams become defense systems. And so you wonder if one day someone finds a way, a better way, to make more, to store more, to use more. What then? You picture the first antimatter warhead. Small. Clean. No radioactive waste. Just silent erasure. A fire that leaves no ash. Would it be the end of weapons? Or the beginning of something worse? These are not questions to fear. Only questions to carry. Because inside every possible danger, there is also a choice. You soften the thought. Let it drift. And return to the present. Where antimatter is still rare. Still precious. Still mostly made for understanding. Where the few positrons we produce light up PET scans in hospitals. Mapping cancer with elegant precision. Where antiprotons help probe the rules of nature. Testing symmetry. Challenging assumptions. Where every particle we trap becomes a lantern in the darkness of ignorance. You smile softly at this. Because maybe the true power of antimatter is not in what it could destroy, but in what it could reveal. It teaches you patience. It teaches you care. It teaches you that energy, at its purest, demands wisdom more than strength. And maybe one day, it teaches you peace. You imagine a world where nations invest in containment, not control. Where antimatter is studied, not stockpiled. Where its beauty is enough. You let that vision linger. It feels far. But not impossible. Because the future is not written in fire. It is written in intention. And for now, the world has chosen to listen more than to launch. To wonder more than to weaponize. You feel that balance in your chest. A soft center between fear and hope. You do not know how long it will last. But tonight, it holds. And as you drift toward sleep, you trace one final thought through the dark. If antimatter is the most perfect energy, then how do we learn to use it? Without becoming its shadow? You lie still. Your thoughts like smoke in the night. Soft, rising, uncertain. Outside, the world sleeps in cities of light and silence. But inside your mind, a question opens like a locked door. Could an antimatter bomb end a city with a sigh? You do not flinch. You are not afraid. You are curious. And that, too, is a form of courage. So you walk through this question gently. Barefoot in a landscape of flame and equations. A speck of antimatter. A sliver, no heavier than a grain of sand, holds the fire of mountains. This, you already know. And so the idea lingers. On the edges of policy and fear. In papers half classified. In the careful whispers of defense labs. Not because it exists, but because it could. You find yourself in a room made not of walls, but of possibilities. In one corner, a physicist sits beside a chalkboard. She draws a loop. E equals mc squared, and smiles without comfort. A gram of antimatter, she says softly, could destroy a city block. Maybe more. But only if you could make it. Only if you could store it. Only if you could survive it. Those ifs are not small. They are oceans. You sit beside her and peer into the past. In the 1940s, the world split the atom. And made the sky burn. And from that fire came treaties. And stockpiles. And dread wrapped in protocol. But with antimatter, the story is different. The idea arrived first. Long before the reality. Science fiction cradled it like a jewel. Tiny bombs in suitcases. Planets cracked in half. Power beyond power. The military noticed. You float back to the Cold War. To laboratories where questions became blueprints. Could antimatter trigger fusion? Could it replace plutonium? Could it ignite, not just explode? The math was enticing. An antimatter pellet, released at just the right moment, might start a thermonuclear chain. Without the radioactive core. A cleaner bomb. A smaller bomb. A ghost bomb, one that vanishes itself. You feel the tension here. Because even in thought, such devices pull at your spine. But the dreams collapsed under their own weight. Not morally. Mechanically. There was, and still is, no way to produce enough antimatter. No way to trap it safely in motion. No way to guarantee it won't vanish en route. Or worse. Ignite before arrival. It's like trying to mail a snowflake through a volcano. You return to the present. Scientists today can hold antimatter. For seconds, in vacuum. In magnetic cages cooled to near zero. But even a vibration, a shift in power, could bring it crashing into the wall. Gone in a flash. With nothing left to use. And even if, somehow, you produced a gram of antimatter, you'd need a magnetic bottle stronger than the sun. Able to fly, to navigate. To deliver and survive the journey. This is not science fiction. This is engineering fiction. You close your eyes and imagine an antimatter warhead. Not a cylinder of metal. But a cage of nothing. Wrapped in fields. Surrounded by systems that can never blink. A weapon that destroys itself. The moment it touches the world. This is the paradox. The impossibility. To build it is to risk losing it. To store it is to guarantee its hunger. So for now, there are no antimatter bombs. No arsenals. No rogue states with secret caches. And still, the question remains. Because where imagination dares to walk, the future often follows. You drift now into a deeper layer. Past the physics. Into the psychology of fear. Weapons are not only tools. They are stories. They are symbols. The antimatter bomb is not feared because it exists. But because it might. And in that might, you find a strange kind of power. The power of potential. Nations have written scenarios. Defense briefings mention antimatter triggers. As hypotheticals. Funding is sometimes requested. Not to build. But to prevent being surprised. And yet, no nation has crossed that line. Not even close. Because nature resists. Because antimatter remains. A terrible friend. Untrustworthy, explosive. And vanishingly rare. You think now about the ethics. Because even if you could, should you? Would a weapon that vanishes without fallout be clean? Or just more tempting? Would its silence make war more likely? Would its efficiency make it easier to forget the cost? These are not questions for bedtime. And yet, they rest gently in your thoughts. Like rain falling on glass. You turn them slowly. Not to answer them, but to feel their weight. Because the danger of antimatter is not in its fire. It's in how we imagine using it. And imagination is where weapons begin. So you come back now. Not to fear, but to fact. And the fact is this. Antimatter is not yet a bomb. Not because we don't want it, but because it refuses. It is too costly. Too fragile. Too quick to vanish. And even the most powerful labs on Earth can barely hold a whisper of it. You feel this truth settle around you. Like a blanket. The science is slow. The challenges are immense. The risks are blinding. And in that resistance, you find comfort. Because some powers, even when dreamed of, remain untouchable. You return now to your breath. You feel the softness of your limbs. The stillness in your chest. You've walked through nightmares without flinching. You've met the shadow without fear. And now, you step out of the room of war. Back into the quiet hallways of wonder. Because there is more to antimatter than weapons. And the next door you open will not be carved with fire, but with questions. Not about what it can destroy, but what it can explain. You feel the shift already. A change in tone. A pull toward the heart of the atom. To the place where quarks swirl in clouds of force. And matter itself becomes a question. And so you close your eyes. And follow the pull inward. Into the proton. Into the particle. Into the storm that holds the shape of you. You float, half asleep. And the stars lean in closer. They have always whispered to your ancestors. From fire-lit fields. From ocean-faring decks. From deserts wide and cold. But now they whisper differently. Now they ask. What if you could go to them? Not in centuries or with sails. But in decades. With speed pulled from the heart of matter itself. This is where your journey begins tonight. In a dream not of destruction, but of motion. The dream of antimatter. As fuel. As fire. As the breath of starships. You move now through the pages of minds. Scientists, writers, engineers. Each one chasing the same shimmer. A spaceship that drinks from annihilation. Because no energy is more complete. When a particle meets its twin, there is no ash. No smoke. Only light. Pure energy, unleashed. 1 gram of antimatter meeting 1 gram of matter. Releases as much energy as 20 space shuttle fuel tanks. More efficient than fission. Far cleaner than fusion. Silent. Invisible. Immense. In the vacuum of space. Where friction disappears and distances stretch beyond imagination. This kind of energy is a promise. A chance to leap, not crawl. You picture it now. A sleek ship, silent and shimmering. Riding on the exhaust of light itself. No fuel tanks. No roaring thrusters. Just a delicate reactor. Where annihilation happens in pulses. Each burst propelling you forward. At speeds no chemical rocket could dare. This is not only possible. It is studied. NASA, ESA, DARPA. They've all traced the outlines. They've mapped the equations. They've written the papers with cautious hands. They call them beamed core engines. Or solid core antimatter drives. In the beamed core version, antimatter reacts with matter to produce charged particles, mostly pions, which can be bent and focused with magnetic nozzles to create thrust. No fire. No explosion. Just particles, streaming in one direction, carrying momentum. You lean in. The idea is real. It hums with promise. But it also trembles under weight. Because to make it work, even a tiny one, you would need nanograms of antimatter every second. And that is where reality pushes back. You remember from earlier. We do not have grams. We do not even have micrograms. We have trillions of times less. Producing antimatter is slow. Holding it is fragile. Scaling it is still a dream. And yet, the dream matters. Because it changes the question. From, can we go? To, if we could, where? Mars becomes weeks away. Jupiter, a month. Alpha Centauri, the next nearest star. Suddenly not forever. You float through that hope. Not to escape Earth, but to understand how big the dream is. Antimatter propulsion is not about power. It's about patience. It reminds you that science and science fiction are siblings. Not the same, but always reaching toward the same sky. You drift now through history. In the 1960s, when rockets first reached orbit, engineers already asked, can we go further, faster, better? And again, they found antimatter waiting at the edge of the answer. But always, the next step was too far. Materials couldn't hold the heat. Fields couldn't control the particles. Nozzles bent or melted. And the antimatter? It refused to behave. Sometimes, it annihilated too soon. Sometimes not at all. So the prototype stayed on paper. The models lived in computers. And the ships? They flew only in fiction. But fiction matters, too. You think of Star Trek, where warp drives hum, powered by matter-antimatter reactions. You think of golden hulls and nebulae, of captains who explore, not conquer. These stories gave scientists permission to imagine what might be, not just what already is. They gave antimatter a face not of fire, but of freedom. And maybe that is why the dream still lives. Even now. As engineers study better containment. As researchers explore lower-energy antiproton traps. As private companies whisper about long-term projects. No one is building ships. But they are building ideas. And ideas, you know, are where journeys begin. You rest your head against the thought. Warm, gentle, star-lined. Because in these quiet designs, there is no warhead. No silence of cities turned to ash. Only a ship, waiting for the right hands. The right patience. The right purpose. And yet, you know the shadow is never far. Because every engine can become a missile. Every fuel, a fire. Antimatter does not care how it is used. It simply is. So the burden is not on the particle. It is on you. You must decide. If your dreams reach toward stars, or fall into ash. And so far, you have chosen wonder. You feel that choice in your bones. A quiet pride. Because for now, the labs that study antimatter, Build rings, not weapons. They ask how, not when. And in that restraint, there is wisdom. You picture again the ship. Not flying yet, but designed with care. A hull lined with superconducting coils. A chamber colder than space. Tiny pulses of annihilation. Controlled like clockwork. And a trajectory. Not toward battle, but toward knowledge. Maybe it never launches. Maybe it takes another century. But the blueprint is there. Waiting. And blueprints, like seeds, have a way of growing. You close your eyes now, letting the dream settle deeper. You are not launching tonight. Only drifting. Only listening. But tomorrow, someone will wake with a new idea. And the path will stretch a little farther. You are part of that path. Simply by imagining it. And as the stars breathe above you, you hear a new question forming. Not about ships, but about what lies inside. What makes matter, matter? And if antimatter is its opposite, what lies deeper still? You lie still tonight, as if the air itself has thickened. A hush so deep it feels sacred. All around you, the universe holds its breath. And at its center, a silent question flickers in the dark. Why is antimatter so rare? Not in theory. In theory, it should be everywhere. A perfect twin to matter. Born in equal measure. But when you look around, you see only half the mirror. You see you. And not your opposite. Where did the other side go? You float into the silence of this imbalance. Guided not by fear, but by gentle wonder. You know by now, antimatter is real. You've seen it birthed in accelerators. Measured in the curl of a positron's path. Glimpsed in the flicker of a PET scan. And yet, it is always scarce. Always slipping through. Why? You begin at the beginning. At the first breath of the universe. When time itself opened like a flower. And energy surged outward. In a bloom of particles and light. Matter and antimatter were born together. Each particle had its twin. A mirror image in every way. Mass the same. Charge reversed. They should have balanced out. They should have kissed and vanished. Like candle to flame. Leaving behind only light. But something tilted the scale. Something small. Barely measurable. Gave matter the faintest edge. For every billion antimatter particles, there were 1,000,000,001 of matter. That one was enough. Enough to survive. Enough to become stars and planets. Oceans and trees. You. And so the antimatter vanished. Burned away in a universe too lopsided to keep it. You hold this asymmetry now like a seashell. Listening to the hum inside. Physicists call it baryon asymmetry. A mystery not yet solved. But deeply respected. Some suspect the imbalance came from differences in decay rates. Subtle, hidden rules. Where nature gave matter more chances to stay. Others search for signs of CP violation. Moments when particles and their opposites do not behave in perfect reflection. These are not errors. They are rules. And rules are how nature speaks. You turn toward these rules now. Letting them guide you into the architecture of what's possible. To create antimatter, you need energy. And not just any kind. You need precision. And patience. And immense amounts of input. In labs like CERN, scientists accelerate protons to near the speed of light. And crash them into targets. In that fiery moment, particles and antiparticles bloom. fleeting and delicate. But always, the balance tips. The reactions are never perfect. Losses are many. Efficiency is low. It's like melting mountains. To find a single snowflake. And once born, antimatter must be caught. Trapped in electromagnetic bottles. Kept far from matter. Lest it vanish in a flash of light. Even when all goes right. The return is tiny. It takes billions of dollars. Years of work. And armies of minds. To produce a few nanograms. This is not failure. This is the price of precision. Because antimatter is not a flame to be stoked. It is a thread of lightning. Held in steady hands. You drift now through the laws that bind it. Conservation of energy. You cannot create particles from nothing. There must be energy to pay the cost. Conservation of charge. You cannot make only antimatter. There must be balance. Matter born alongside it. Thermodynamic limits. The more ordered your creation, the more energy you must spend. To defy entropy's gentle chaos. These laws are not punishments. They are protection. They are how the universe holds its shape. And inside these laws, antimatter remains. Rare. Beautiful. And fiercely guarded. You understand now. Why nature is slow to release it. Because too much power, given too freely, invites misuse. And the universe has learned to hold its fire with care. You breathe in this wisdom, feeling not frustration, but calm. Because limitation is not a wall. It is a doorway. One that requires intention to cross. And scientists are learning how to knock, how to listen, how to ask without forcing. There are hints of progress. New traps with longer hold times. More efficient particle collisions. Ideas to use lasers. Plasma wake fields. Anti-hydrogen cooling. But each step is small. And each success fragile. Because for every answer found, there are 10 more questions waiting behind it. Why does antimatter fall the same way as matter in gravity? Does it feel the same weight? Could the universe hide pockets of antimatter galaxies in corners too distant to see? Some experiments, like Aegis and Alpha G, are listening now for gravity's whisper, hoping to watch antimatter fall. Not just vanish. If even one rule is different, even slightly, then everything we know must bend. Just a little. You cradle this possibility. Not as threat, but as wonder. Because antimatter, in its absence, still teaches. It teaches symmetry. And how breaking it creates form. It teaches scarcity. And how value is born from rarity. It teaches patience. And how power that waits is not weakness, but wisdom. And so, tonight, you do not ask for more. You do not rush the laws, or demand shortcuts. You simply float through what is, and what might be. You close your eyes now, drifting deeper, feeling the careful fingers of physics rest on your shoulders. They are not trying to hold you back. They are trying to teach you rhythm. The rhythm of stars. The balance of birth. The measured dance between energy and form. And as you fall into sleep, you carry one thought gently forward. If nature guards her brightest flame with such care, what else might she hide? Not from fear, but from love? You drift backward through time tonight. Not to chase ghosts, but to listen for the hush they leave behind. The Cold War hums like a distant storm. Not thunderous now, but soft with age. Like a song no longer sung aloud. And yet, it lingers. In memory. In metal. In papers once locked behind steel. You slip into those archives now. Slowly, respectfully. As if entering a cathedral of fear. Because for a time, the brightest minds were asked to imagine the darkest things. Not for curiosity, but for control. You are shown a file. Yellowed at the edges. The title reads like a riddle. Low mass annihilation energy sources. Your breath slows. You know what it means. You know what it tried to become. A weapon made of antimatter. In the 1980s. As satellites watched the skies. And bunkers were built beneath cities. A strange possibility rose into classified conversation. Could a gram of antimatter, small, silent, invisible, replace the need for radioactive cores? Could it be a cleaner trigger? A perfect initiator? One that vanishes after it speaks? The Department of Defense wondered. So did the Soviet Union. So did quietly funded labs. With blank doors and unspoken names. And though the budgets were small, the ideas were sharp. You step into one of these rooms now. As if watching a play. A physicist stands at a whiteboard. He draws an implosion lens. Classic, familiar. Then he replaces the center. No longer plutonium, but an antimatter capsule. His chalk squeaks. The capsule is magnetic. Held in place by precision. When released, it kisses matter. And from that kiss, a burst of energy. To ignite fusion fuel. No fissile residue. No chain reaction. Just light. The perfect bomb. At least in theory. You pause here. Because something about that phrase feels wrong. Not just morally. Physically. So you listen to the scientist explain. And you hear the hesitation. Even beneath his excitement. Because to use antimatter like this, you must solve a cascade of impossible steps. You must make it. Not in nanograms. But in milligrams. You must store it. Not for seconds. But for days. In a form that moves. But doesn't touch matter. You must trigger it. With perfect timing. Perfect stability. Perfect silence. And you must do it. Without letting the world see it coming. The military dreamed. But physics refused. Because every design ran into the same wall. Fragility. Even the smallest disruption. A bump. A field shift. A micrometeorite. Could unleash the energy early. Not as a bomb. But as a firefly. Swallowed in its own flame. And even if built, such weapons could not be stored. Shipped. Or deployed. Without enormous risk. They were not tools. They were traps. You float now through another scene. A hearing, deep underground. Officials speak in code. They reference advanced triggers. Theoretical enhancement pathways. And exotic energy vectors. But what they really mean is this. They're scared. Not just of enemies. But of ideas. Because if even one nation could build an antimatter bomb, then all stability crumbles. Treaties fail. Detection becomes impossible. The unthinkable becomes small enough to fit in a backpack. So the response was silence. Programs were paused. Budgets faded. Research drifted quietly. Back to particle physics. Away from war. The weapon never came. Not because it was forbidden, but because it was unrealizable. And in that failure, you feel a strange peace. Because here, at the edge of ambition, nature whispered no. Not with cruelty, but with the soft hand of impossibility. You walk through this now, like a hallway where every door leads nowhere. And for once, nowhere is enough. The Cold War ended. The files were unsealed. And inside them, you see not monsters, but minds trying to solve puzzles they did not always believe in. You do not judge them, because fear bends even brilliance. And the Cold War was made of fear. Mutual assured destruction. A doctrine with no exit. And antimatter? It was a flicker in the margins. Too rare to use. Too powerful to ignore. Some theorists kept sketching ideas for low-yield battlefield devices. Concepts for space-based detonations. Radiation-free clean warheads. But always, the math collapsed. The costs spiraled. The practicality faded. You sit with that fading now, as if beside a fire, burning low in the wind. The dream of the perfect bomb did not die. It simply dissolved. Into curiosity. Into funding shifts. Into questions asked more gently. And from those ashes came something better. Because the same science that flirted with weapons also built detectors and PET scanners and the Large Hadron Collider. The same minds who drew up annihilation models later turned their gaze to cosmic rays, to antimatter's behavior in stars, to the heartbeat of the early universe. From fear came understanding. From tension, discovery. You breathe into this reversal. It feels like forgiveness. You drift now through the final pages of that era. Some still speak in shadows. There are papers, rumors, memos without authors. But they all echo the same truth. The antimatter bomb was a ghost. A ghost too heavy to lift. Too fragile to hold. Too hungry to keep. And the world, perhaps unknowingly, chose peace through impossibility. You return to the present now, with a strange lightness. Because not all dangers come true. Not all paths become roads. Some remain dreams. Or nightmares. And then dissolve. That, too, is worth remembering. Because while the future remains uncertain, the past sometimes softens. Under the weight of what didn't happen. You hold that silence now. Not as emptiness, but as a kind of gratitude. Because in a century shaped by war, there were some weapons that never made it off the page. And perhaps the most powerful ones never will. But even as you close this chapter, another question stirs. If antimatter is not a weapon, and not yet a tool, then where does it belong? You feel a pull again. Not toward Earth, but outward. Toward the stars. Toward the rare cosmic collisions, where antimatter still flickers. In the shadow of light. You lie still, softer than breath. Wrapped in the folds of a question. Not one with sharp corners. Or urgent edges. But one that floats. Like a feather in a still room. You followed antimatter. Through origins and collisions. Through bottles and bombs. Through hopes and silences. Now, you arrive here. Not at an answer. But at a doorway. The doorway of what it means to know. Something so powerful. Yet so fragile. To hold a thing made of annihilation. But also light. To cradle possibility. Without letting it spill into destruction. Antimatter has shown you many faces. The twin. The fire. The whisper. The mirror. The dream. And in each, you've seen not just physics, but choice. Because the question that remains now is not how to build a better trap, or a faster ship, or a cleaner weapon. The question is, what will you do with this knowing? You are no longer just a listener. You've walked through history and laboratory, through silence and spark. And now the science rests gently in your hands. A soft flame. Too bright to own. Too dangerous to forget. You trace it with care. 1 gram of antimatter can release the energy of an atomic blast. But that same energy, focused, slowed, contained, can scan your body for healing. It can trace the pathways of thought, reveal the shape of tumors, map the living heart, without ever touching it. A paradox, held in the palm. Antimatter doesn't know right or wrong. It doesn't choose purpose. It is only what it is. The opposite. And so the burden, the beauty, rests with you. You reflect now on what it means to walk with such a shadow, without becoming it. Other powers have come before. Fire. Electricity. The atom. Each began as mystery. Then miracle. Then weapon. Then tool. And each time, humanity stood at the edge. And asked, quietly or not, what now? You feel that question tonight. It hums at the base of your breath. What now? What do you do with a thing that vanishes upon contact? That lights the dark without residue? That cannot be seen, but can end a city? You don't answer yet. You let the question settle, as if lowering it into water. There's something sacred about hesitation. In science, it is called caution. In philosophy, ethics. In the body, a heartbeat before movement. The truth is, we are good at imagining harm. We are slower at imagining care. But slower is not weaker. It is wiser. You remember CERN. Not just as a machine, but as a temple of restraint. A place where people chase knowledge, not conquest. You remember the antimatter bottle, hovering inside invisible fields, held not by force, but by understanding. This is how you hold power gently. Not with fear, but with reverence. To know something intimately, and still choose not to use it for harm. You look now at the broader night, the dark canvas of possibility. You see futures unfurling, some golden, some gray. In one, antimatter fuels starships. Each reaction a soft push toward another world. In another, it heals. It maps the mind. It answers questions about the first seconds of time. And in others still, it never leaves the lab. Not because it failed, but because we chose not to force it into form. All are real. All depend on us. You let that sink in. Not as burden, but as invitation. The universe is full of energy, but only you can give it meaning. You rest inside this thought now. There is no final moment of discovery. No last chapter in physics. Only better questions. Softer thinking. You imagine a child, 100 years from now. Reading what you've learned tonight. Not with fear, but with wonder. They will not be amazed at how fast you traveled, or how much energy you controlled. They will ask, what kind of world did you build with it? And your answer will not be in equations. It will be in how gently you held the shadow. You close your eyes. And for a moment, the antimatter flickers inside your mind. A breath. A twin. A silence. You don't fear it. You respect it. Because to love something is not to use it. It is to know it. And let it be what it must be. And so, as the final page turns, you are not closing the book. You are stepping out of it. And into yourself. Carrying the science with you. Not as armor. Not as fire. But as a light. You do not rush to ignite. You sleep now. Not with endings. But with beginnings. And as the stars watch, you let one last question rise like mist. If antimatter is the opposite of matter, what is the opposite of fear?